Alright, so without further ado, let's look at some examples here. Actually, they're just 2 examples, so don't worry. Okay, the question is actually taken out from your example 3.1b on page 27 in the module. This question is about checking whether which soil is suitable as a transition filter for an earth dam. So I'll just quickly go through the question. It tells you that the fine grain soil is to be protected. So the fine grain soil obviously is a clay that's being used to create your earth dam. Alright, has to be protected with a transition filter, and it's given that the D15 is such and D85 is such. And the 3 soils that are going to be used as your filters, the 3 possible soils, alright, they are the candidates or the potential ones, given the D15 and the D85 are all given here. So all you need to do is to fulfill the criteria by using the equation there, right, that we have seen earlier on. So for soil A, as you can see, if you pop it in and check out for D15 over D15 of protected soil, see that it's greater than 5, it's not okay. For the second criteria, migration against the migration of fines, then it's okay. For soil B, the first criteria is okay, second criteria is also okay, it passes for both. For soil C, it passes one and it doesn't pass the other one. Hence, you can say that yes, soil B fulfills both, all 3 criteria can be used in a transition filter. Now you may ask, 3 criteria, you say there are only 2 here. Well, the third criterion they were talking about, remember it was given the question. The question told us the grain size distribution curve of all the soils has about the same general shape, because the third criteria is actually that the gradation curve should be about the same. Okay, so remember that. Okay. Now, another example here, again, is from your module 3.5, example 3.5, page 47. Now, in the case of a flow in a layered soil, right, it's a stratified, means a layered soil, approximately alternating layers of sand and silt. Sand 150 mm thick, and certain this permeability, coefficient permeability, and the silt is 1.8 meters thick, and the permeability of such. Note that when we talk about coefficient permeability, the K value, it is the power that we are interested in, 10 to the power of negative 1 for a sand, and 10 to the power of negative 4 for a silt. Which one is a smaller number? Obviously, 10 to the power of negative 4, right? And it is for the silt. Silt is finer than sand, so it is logical, it makes sense that silt will have a lower coefficient of permeability compared to sand, meaning that water flows much more slower through silt than sand, okay? And assuming that each layer flow conditions are isotropic, they want us to find what is the ratio of horizontal permeability to that of the vertical. So first and foremost, like we always say, draw all the information you have. So they tell us that you have layers of silt and sand, and the sand is actually being sandwiched between your silt, because the sand is only 150 mm thick and your silt is 1.8 meters thick. Okay, and in this case, we just need to consider a pair of them, meaning that a single layer of sand and a single layer of silt, because the question wants us to identify what's the ratio of the horizontal to the vertical permeability. Okay, and here we go. Just take one cycle, that means one pair of it. The equation for your coefficient of horizontal permeability, KH, is this, is given here. So just pop in all the numbers, D1, K1, so D1 is what? D1, you're referring to the sand layer, the thickness is 150 mm, so pop it in here. So K1, of course, is the K value for your sand, and D2, K2 refers to the silt. So take the D2 and the K2. Remember, in this case, you'll probably be asking, why is this becoming 6,500? Because we want to take out the power of 10 to the negative 4. So 6.5 times 10 to the power of negative 1 is the same as 6,500 times 10 to the power of negative 4. Correct? It's just simple mathematics. You know that, don't worry. Divided by the total thickness of both. And you find that this is the answer. Okay, don't forget the 10 to the power of negative 4 there. Don't drop that first. And similarly, for the vertical permeability, the equation is such, you can see that they are slightly the other way around compared to the KH. So pop in the numbers again similarly. Don't forget the 10 to the power of negative 4. If you don't like these, you want to put it in there, it's up to you, okay? And just make sure you don't get them wrong, and this is the answer you get. So the question says what? The question wants us to find out the ratio of it, KH over KV. So all you need to do is to take the sum of KH divided by KV, and that's what I do here. In the example in the module, they have put in the long calculation for you. So roughly it's 185.47, so it's about 186. Okay, so that's it. Any question, you can PM me or just WhatsApp in the group, things like that. So make sure you do your revision, learn well, and stay home and stay safe. Bye-bye.